So what is a function? Well, the idea of a function, I think, comes from the idea of a function in mathematics, and that is your f of x. You had an independent variable x, you fed it into your function f of x, and it spit out a y in output. And so this setup, this paradigm we use in programming, where we literally create functions that take in parameters and some sort of independent variable input, performs algorithms or tasks based on this input or these inputs, and then spits out or returns a value. So let's look at some code. Alright, so the most basic form of a function is this. We have, of course, the function keyword here, signals to JavaScript that we want to create a function. We have the name of the function, treat it like a variable name, so all the rules apply. No reserved names, no names that start with numbers, has to start with a letter or an underscore or a $sign. And then we have the parentheses, and this is where we would put the input, or a signal to the JavaScript that we want, some sort of input for a function. We don't want input yet, so of course the parentheses are left blank. And then we have the body of the function. In this case, it just says to log the word or the string hello to the console. And of course, we have these curly braces, which tells JavaScript that all of this code within the body of our function is to be treated as one nice package. So when we call our function, run all of this code. We just have one line of code. So let's go to our browser and paste this and see what we get. Open up your Chrome or your Brave, Control-Shift-J or F12, and paste and enter. So we've just defined a function called say hello, and it just does one thing. It logs the word hello to our output. And so to call the function, we use the function's variable name, or the function name, and we hit enter. But unlike a variable, if we do not use the proper syntax for calling a function, the REPL will just spit out the literal string of the function. So in this case, it's the say hello, open and closing parentheses, blah, blah, blah. So to call a function in our REPL, we have to include the parentheses. This tells the REPL to execute the actual function. And so we execute the function and we get what we expect, the string hello logged to us. Now let's take a look at a function that takes some sort of input, some sort of independent variable or variables. So back to the whiteboard. We'll do another paste here, and we'll move that over. So this function takes two numbers, adds them, and returns the additive. The sum. So of course we have the function keyword. Let's try and do the same color. Function keyword. We have the function name. No spaces, right guys? Just use underscores if you want spaces. And then we have the parentheses, but this time we have parameters. So quickly, the idea or the definition between a parameter and argument. So parameter is in the function definition. So num1 and num2 would be our parameters. But when we use those parameters in the block of logic of the function, we refer to these parameters as arguments. So whether you use the term parameters or arguments, it depends on which way you're looking at the variable. So we have the num1 and number 2 parameters. Of course, we have the curly braces, which define the function block. And then we have our code or block or logic. In this case, it's going to create a variable, a constant variable named sum. And then into it, it's going to pass the value of our arguments num1 and num2 added. And then it's going to return that value. We'll get into this in a second. Returning is not the same as printing to your console. So let's go ahead and paste this into our browser, see what we get. All right. So paste. We've just defined a function called add these numbers, takes two parameters, num1, num2, adds these two arguments, returns the sum of these arguments. So let's go ahead and call the function. And remember, when we want to call a function, we have to use the brackets. And for our first parameter, we'll put 5, second parameter, we'll put 2, and we hit enter. Now, it gave us a 7. In your normal programming environment, you're not going to get a 7 back, because in our function block, we didn't say to print anything back to the console. But since our REPL reads code, executes code, and the way it's set up, it'll return the value of the function. So when you're actually programming, if you want to capture the value of that function, you have to put the value, the return value, into a variable. And so that would look like this. Declare a new variable x. We're going to make that variable, the value of that variable, into the return value of our function. X has already been declared. Let's try y. Add these numbers, 5 and 2. And then we print out what y is, and y is 7. And so we created a variable called y. We put the value, or assign the value of y to the return value of our function which adds two numbers, the numbers 5 and 2. And finally, let's tackle the idea of scope. What is scope in programming? It's basically the idea of where your variables are born, and then the rules to where they can traverse. And so let's think of scope as a series of concentric circles. Let's get our guy here, move over a bit. So this would be a scope or a region. That'd be another scope or another region. This would be another scope or another region, and another scope or another region. And so say we had a variable born or instantiated or declared in this region here. And this variable could traverse into this region, and this region, and of course traverse back to its original region. If we had a variable declared here, this variable, of course, would be able to traverse into these inner regions, and of course back into its original region, but it would not be able to traverse outside its original region. And so we have this behavior where a variable is born, it can traverse inwards and back to a limit. And what's that limit? The place it was born into. So let's go ahead and copy and paste another piece of code, and hopefully it will illuminate what I'm talking about. There we go. All right. So this piece of code, all it does is define two scopes, but there are three scopes at play here. One scope is always going to be true, and that's the scope of the actual program. That's the most general outer ring. When you define a function, you define a specific scope, or a new place for variables to be born into. And so we have the first scope, our most general scope, which is the scope of the entire program. And we have three different variables with the same name. Now, if we just declared three different variables with the same name in the same region of the same scope, we get an error. But because we're declaring these three variables with the same name in three different scopes, we can get away with this behavior. And so that's our scope 1. We define a function inner scope 1, which creates a new scope. And that function has its own version of const immutable, and this one's equal to 200. And then we have another function, inner scope 2, which creates another scope, and then that function has its own version of const immutable, and that is of course equal to 999. So let's go ahead and paste this code into our browser and see what we get. All right. So we've declared three different variables, same name, three different scopes. Let's print out the first immutable. We'll tell REPL to give us the value of the first immutable, the most outer region, the outer scope. Of course, it's 5. Now, we're going to call inner scope 1. What this function does, it's going to take a parameter. We're going to pass in our outer scope's immutable. It's going to print out the value of that immutable. It's going to create its own immutable, print out the value of its own immutable. It's then going to call inner scope 2. What inner scope 2 does is creates its own immutable and then prints out the value of its own immutable. And so when we run this code, we should expect to have 5 and then 200 and then 999. So let's call the inner scope 1 function. There we go. And we'll pass in as a parameter the outermost scope or region's immutable variable. And we get the outer immutable is equal to 5. Create our own immutable. The inner scope 1's immutable is equal to 200. Call inner scope 2, create our own immutable, and the inner scope 2's immutable is equal to 999. And so all this exercise does is show you that you can get away with naming your variables the exact same name, but because they exist in different scopes, they're born in different regions, they can sort of coexist. They can travel inwards, but not outwards. If we were to say try and print out our inner scope 2's immutable in the outer scope, what we get is immutable. We get 5. And so the outer scope only knows about 5. It doesn't know about 999 or 200. So just this behavior of you can go inwards and outwards to a limit. What's the limit? The place you were born. All right, so we covered a lot in this video and the video before this one, in this sort of sub-series of introing the basics of Java, and we haven't even scratched the surface on the basics. But when we need to get into more stuff, we'll definitely get into more stuff. So let's sum up this video and the video before this, since these two videos actually dealt with like programming, practical programming. And so we should have an idea of what a variable is, a mutable or immutable placeholder or moniker that points to data in our program. We should have an idea of what a function with or without parameters is. It's this defined block of logic that, based on an input, if there is an input, it executes some sort of logic, some sort of algorithm, tasks, and then it returns a value. We have, or should have, a basic understanding of what scope is. And again, if you don't completely understand the scope thing, don't worry. That just comes with time, with programming experience. The idea of scope, that a variable born into a region can traverse into all inner regions, but it can't traverse outside of the region it was born into. And then we should have an idea of some basic programming syntax or norms. Function keyword, variable keywords like const or let. Naming conventions, you can name your functions and your variables with letters, underscores, dollar signs, but you can't start them with numbers or reserved words, things like that. And so in the next few episodes, we'll be taking a look at how JavaScript is used in the web development process. And so we're going to define things like front end, I think, business logic, back end, server logic, all of these good things. So if you find value in any of this, of course, like, share, subscribe, thumbs up, vote up, whichever platform you're watching this on, all that good stuff. I will see you guys in the next one.